I will say yesterday's people are continuing to like trickle in and continuing to get this assignment done, and I love that. I love that. This one of the benefits of what we're doing is you kind of get to do it at your own pace and on your own time. So some people are doing it like right in the morning, some people are waiting until the afternoon, some people can only get online every other day or whatever. Whenever you can get online, do what you can. I love going back. I'm having such a kick out of going back and looking over at, who just finished it and who's saying what and how everyone is like thinking about this. So keep up the good work. I love, love, love reading what everyone is writing. Um, yeah, very, very cool. Very, very cool, everyone. Um, all right. So I'm still not, I don't know if my chat's frozen or if people are just kind of like chilling today, which is fine. Um, but the one thing, I'm going to do a bit of a transition now into uh, some like real talk about how we speak about these things. So let me kind of create a parabola that kind of looks like some of the stuff we've been looking at, and something like that. And something like that. Okay, so we've got this parabola, right? And maybe this parabola, when we think about like gravity, maybe we're thinking about this being, a basketball. Basketball or anything that's being like thrown, you know. And so, someone throws it up, it comes back down, or someone kicks the ball and it comes back down and all of that. So I want you guys to start. And when you're doing this, if you're watching this video later, I would tell you to pause and go get out a pen and a pencil and like copy some of these notes down with me. If you're doing this live and you have a pen and pencil or a pen and paper or pencil and paper handy, go get it, go do that and like write some of this down as well. We do it. If you don't, that's fine. I'm just happy that you guys are here listening in and hanging out with each other. So we've got this parabola. And like, I don't know if anyone's like just said it, so let's say it. This shape is a parabola. Right? When we talk about this shape is a parabola. Notice up here there was a different word, quadratic relationships create parabola shapes. It's the same way that like linear equations make lines, but it's a different word. So quadratic relationships make parabolas. Why do we have two different words for this? I don't really know. I have a suspicion it's like a Greek and Latin thing. So I think the word parabola sounds very Greek to me, but the word quadratic sounds very Latin. So I think it's part of our English heritage where it's the same idea, but we got the shape from one root language and we got the relationship from the other root language. I will do more research on that, but I think that's what's going on here. That would be my guess. Okay, so when we look at a parabola, one thing that keeps coming up is this point up here. So the last image of the basketball, right? The highest point in the curve. When you were doing these Desmos assignments, I'm over here now, it's the purple dot, right? This has a name. Let me do this in a different color. This has a name. And this is called the vertex. This is called the vertex. And in this parabola, this vertex is the highest point of this shape, right? People call it like, I've seen people call it like an N shape in some of the other assignments you guys have done. I've seen people call it an upside down U or an arch, but the vertex is this point. That in this case, it's the top of the parabola, but we can call it the maximum. But the vertex is not always at the top of a parabola. And you guys saw examples of this for everyone who did that activity yesterday, right? I can change my parabola. And now the vertex, right, because it's still called the vertex, is not at the top of the parabola, but because it's the other shape, it's now at the bottom of the parabola. So we can call this the minimum. Minimum. Right. Maximum if it's at the top. Minimum if it's a different looking parabola, if the vertex is at the bottom. And then one of the things that makes a parabola is something that everyone who did that basketball assignment was using, I think, intuitively, which is that when the basketball went up, and the last image was here, everyone was thinking like, okay, after the vertex, what's going to happen? First, the ball comes up, but then after the vertex, it's going to come down. And not only is it going to come down, but it's going to come down in the same way that it went up. This idea mathematically is called symmetry, that the curve on one side is going to be mirrored by the curve on the other side. So we say that parabolas all have symmetry. And that symmetry always happens across the vertex. So here, and honestly, I have a strong suspicion that I'm probably just telling you stuff you already know. But maybe the thing that I want you to think about is like the language here. So we say that the fact that parabolas are the same on the left and on the right, we say that that is symmetry across how do I want to say this? Symmetry across the vertex. And I'm going to use a different color because I'm kind of doubling up on my words here. But this line, this dashed line that I just created, we call the line of symmetry. And I saw people use this a lot on the first activity we did on Wednesday, where people were like, oh, well, I knew it would pass through both gates. If I made it line up on one gate, I knew it would kind of line up on the other gate. So that's that idea that like if I do something on one side, whoop, it'll mirror it. It'll be symmetric on the other side, right? That's that idea about symmetry. All right, the other thing that I want to talk about are some keywords that we use all the time, but we don't necessarily, let's just do this. Yeah, okay. But we don't necessarily spell it out. So when we talk about quadratic relationships, parabolas having a vertex and parabolas having symmetry is something that kind of happens everywhere you see it, right? Shooting a basketball. water coming out of a fountain. All of these things you can really easily be like, well, there's the vertex, there's the symmetry, right? Once you put the same parabola, but you put it on a graph, there are other things that become important because it's on a graph. And these things are, let me write them down here. These things are the y-intercepts and the x-intercept. And this is true for lines, it's true for exponential equations, and it's true for parabolas. We're not saying that parabolas are special because they have a y-intercept. We're just saying that when you graph parabolas, the y-intercept is something you should think about. Right? And when you graph parabolas, the x-intercept is something you should think about. So when you look at this, this example over here, right? Here's my vertex, very important. Remember, the x-intercepts are where the parabola crosses the x-axis. So like, take a minute. If you're watching this on a video, pause it in a second. But identify for yourself, first of all, how many x-intercepts does a parabola have? That is, how many times does the parabola cross the x-axis? And two, what are the x-intercepts? Where does the parabola cross the x-axis? Right. So x-intercepts. And then same thing for the y. Right. Where does the parabola cross the y-intercept? And how many times? So yeah. So if you are watching this video, pause the video and see if you can figure those things out. I will delay for people in chat as well. Can you find the x and y intercepts here? Oh, hey, doggy. Oh, you don't want to come say hi? Okay. Here's what I'll do. So what I'm going to do really quickly while you guys are answering those questions is I'm going to make some movable points on Desmos. You guys care what color they are? Figured I'd do like one of each. I'm gonna make a green one, I'm gonna make a blue one. And I'll make a orange one. So here are my points. Projector mode. Yeah, Betty? You wanna see everything? No. Okay, all right. Guys, hold on. I think I gotta go let my dog outside. I'll be right back. Okay, all right, let's talk about this. So, y-intercept. So the y-intercept is, again, where the parabola crosses the y-axis. And so I can just take one of my points, just so we all know what we're talking about. So y-axis is this axis right here, right? This is the y-axis. So if I want to figure out where it crosses, it looks like it crosses the parabola, crosses the y-axis, right about there. Which if I were to estimate 1, 2, 3.5. So I would say the y-intercept of this, where am I? Of this example would be at 0, 3.5. Give or take. Let's move this up. Okay. X-intercepts. So you might have already picked this out, but this parabola has 2 x-intercepts. So one of them is right here. And the other one, oh, there's already a red dot there. The other one is right there. And so for this one, we'd have to write 2 x-intercepts. So this x-intercept, counting 1 to the left, is at -1, 0. And this x-intercept over here, 10, 11, is at 11, 0. So when we start talking about vocabulary, right, we say that the parabola, oh, maybe we should do this right now. Let's do this right now. Last thing, vertex. What are the coordinates of this vertex? This is a good question. So the vertex is obviously right here. We've talked about it a lot already. That's why I say it's obvious. But this point is at 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So this vertex is at 5, 11. Boom. Ta-da! And so that's it. So when we talk about kind of what matters in what kind of vocabulary do we want to start using for parabolas, this is the language that I want you to start practicing. I want you to start practicing saying, oh, there's symmetry, or there's the line of symmetry. I want you to start saying, you know, there is a y-intercept at 0, 3.5. There's an x-intercept at -1, 0 and 11, 0. And I want you to say that the vertex has the coordinates 5, 11, right? Like I said, these are things that you already notice. Hopefully I'm not like telling you anything new. This is mostly like, how do we want to start practicing talking about it, right? So in activities moving forward, I'm going to start using this language more, right? I'm going to start saying vertex instead of saying purple dot, right? Or instead of saying the last point of the basketball, we want to start saying vertex. Right? So I'm looking at the time, and we're at about an hour, which tells me it's probably time to cut it. So I will leave you with this last question. I gave you an example of a parabola that has an x-intercept here and an x-intercept here. That's 2 x-intercepts. So my question to leave you guys with, and I'll write this down here. The question is, do all parabolas have 2 x-intercepts? That is it possible to create a parabola that has something other than 2 x-intercepts, right? Do all parabolas have to cross the x-axis twice? So I will leave you with this, and we will probably talk about this more on Friday. I will be streaming again on Friday, but until then, please be safe, please be sane, and please be kind to yourself and to others. I care about you all a ton, and I hope that you are all doing great. Know that I am so, so proud of all of you. All right, everybody, take care.